Dental malocclusions are commonly found dental issues among the normal population. From modern studies, malocclusions have shown a 56% of prevalency worldwide without differentiating between genders. Contradicting to how common malocclusions are, the awareness of such an issue and the willingness to seek treatment has been low among the public, even as the World Health Organization has stated that malocclusions are one of the most important oral health problems. As further studies have shown, even though the majority of the population claim to care about their oral hygiene, 66% claim that they only seek oral health checkups only if necessary. In the past, there have been a few researchers that have incorporated image processing in the dental industry. Their targets have been for treatment planning, and they have used medical imaging technologies such as radiographs as their input, or have used heavy laser scanning equipment for scanning. For example, a research named Automatic Feature Identification in Dental Meshes, conducted in 2012, have used clay sculptures of patients' jaws and used special laser scanning equipment in order to scan these dental meshes. These dental meshes, after scanning, were rendered as 3D models in order for be used as treatment planning or treatment predictions. As mentioned, there have been other researchers that have incorporated dental imaging technologies such as X-ray in order to detect other types of dental issues. As an example, there have been a few researchers that have been using X-ray technology, and they can be named as teeth detection and dental problem classification in panoramic dental X-ray imaging using deep learning and image processing techniques, and other researchers such as image processing of panoramic dental X-ray images for identifying proximal caries. As such, we can understand that most of these researchers have used medical imaging technologies in order for their detection, and have mostly used for treatment planning. This project attempts to provide a modern approach to dentistry by providing potential malocclusive patients to identify whether they have dental malocclusions with the comfort of only using simple digital images. When considering a layered architecture, the system would consist of two tiers. We will start with the presentation tier. The presentation tier will consist of the user interface. The user interface has the processes of either with the detection form or with the analyze report. So the user will first interact with the detection form. The detection form will hold certain information that the user must enter along with an occlusive image of the patient's teeth. So after the user has entered the information, it will get transferred by the REST API into the logic tier. In the logic tier, the data will be processed and then will be transferred to the YOLO detection models. So under the detection models, certain information will be created from the image that we have entered, and with that information, the data will be transferred from the backend to the presentation tier by the REST API, and then the newly detected data will be used under an analysis, and then will be presented to the user as a detection report. Now we will take a look at the sequence diagram. So first we have the user, and the user will enter an image to the user interface. Then the REST API will transfer that image to the backend, and after the image arrives in the backend, it will go through the process of the detections. So in detections, we would have three layers of detection. So first we have the malocclusion detection layer, then we have the severity detection layer, and then we have the location detection layer. So here we will first send the image to the malocclusion detection layer, and after the detection is concluded, the results will get transferred back to the backend, and if certain conditions are met with the detection results, we will transfer the image to the severity layer, and in the severity layer we will detect for severity, and after the detection is concluded, we will send that information back to the backend, and if certain are conditions met here as well, we will transfer that image to the location detection, and after this detection has commenced, we will send all this information back to the backend. So after that, uh, we will basically structure and analyze the data that we have formed from all the detections, and then we will send it to the user interface, and with the user interface we will be able to display all this information as a report to the user. So this is a demonstration of our application. It provides you with a few functions. We'll firstly go into the informations page, so we'll click be informed right here. So after we click here, we'll get three options of the three options here. Like these individual options will provide different kinds of information depending on what you prefer. So if you would like to so in order to use the system correctly, we will provide you proper instructions on how to take the correct image. So if we can go into this panel here, we can actually see now. This section provides in detail information of what kind of aspects that you need to be wary about when you take the picture and whatnot. So to extra precautions in order to get the best results out of the system. So and we can then move on to malocclusion. So here we can actually see all the information related to dental malocclusions and what they are, the classifications, what are the different types of it as such. And finally, if the user seems to be suffering from a severe case, we provide contact information of professionals in order for the user to um, communicate the uh, uh, professional surgeons as soon as possible in order to get either seek professional help from them. And now we can move on to the detection process. So we can click here to get started with the detection. Okay, so here we will be presented with the form. The user must fill this information first in order to proceed with the detection. So I'm going to fill my information here. We'll be filling age now, my gender, and if the user is suffering from like either one of these medical cases, they'll have to tick the checkbox right here as such, because this may affect the overall treatment plans coming on next. So and one of the other key aspects that we have to mention is the entering of habits, as habits can influence these kinds of malocclusions to occur. So if they have these kinds of like thumb sucking or finger sucking habits, they might need to enter that as well. Next up, we will enter the image here. So I'm going to find my image that I've taken before. I have selected as such, and I will click submit. So as you can see, it says that you have successfully submitted the your information, and please give a moment for the process to commence. Okay, so as you can see here, the detection process has commenced, and we have gotten a an analyzed report of the results. So here we'll be given the user information, name, age, and then we will have our first detection result as what is the occlusal status. So we have gotten anterior spacing with the severity of low here, and then we'll be have then this is the input image that we have submitted to the application, and it will show based on the based on the detected type of or the classification of the malocclusion what kind of information that you can expect to see as output. So as you can see here, since we have gotten spacing, we'll be able to see this we'll be able to see the state of the occlusal status, the severity, and the location of the spacing itself. So here this is the main detection result. So we have gotten spacing here, and then a small description about what is spacing, and here we have the severity detection. So here we have received a low severity, and then the small facts about what you should be cautious on when you have this kind of severity for this kind of condition. And then we have the location detection. So as you can see, there's only one place that has been detected, so it's very minimum, and then the severity of this can be a bit lower. And as such, one of the key aspects of this application is that the user must enter their age, because the age is very important for treatment. As you grow older, age will affect overall healing of the body. As such, then if someone's older, we would basically we will not approve of treatment. So let's try out one more result here. Let's go back. Let's go back to detection again. Let's try a different example here. 5 male. We'll enter some random health issues here. So let's see to give an example of what kind of result we can get. We'll enter something like this, and we will wait for the result now. And as such, we have received our results. So we have got an anterior crowding, severity of high, and as you can see, the same type of results are showing here as for status, severity, and location. Here's the main detection here, and information of what the conditions of high severity under anterior crowding, and then all the locations that have been detected for crowding. So it's kind of a high amount of locations that have been detected. And then under like the under the health conditions that we have entered, we have provided the user with some information that what they have to be aware before going to treatment, and facts such as that. And then we'll be giving a basic analysis on their age and what kind of treatment plan that they can go for, or if they can actually go for treatment at all. So here we would say, since we have entered the age of 55 here, we have discouraged treatment overall. The following demonstration is the explanation of the code of the Simply Say E application. So the whole process of will commence with the user entering the information on the form and clicking on the submitting button. So this is the code for the form, and after the user have completely filled all the information, they will click on the submit button right here, and that will basically proceed to this function right here. Now we'll go to our TypeScript file. So in the TypeScript file, we'll basically the clicking the submit button will initiate this function from starting. So we have basically declaring these variables of user input of image, name, and everything. Then we will basically we'll see if the user have correctly entered the corresponding information, and if such they have not entered the correct information, they'll receive please enter the name correctly or the age correctly, please enter an input of image and such. And after we will basically these are all verification of the certain variables that the user have entered. And then we'll be after here we will be basically checking all the check boxes if the use what the information what kind of information that the user have entered, and here will be comprising all of those information into one object, data object here. Here the image that we be using using here, the image is initially converted to converted to byte form right here using these two functions right here that we have implemented. And then after the object has been created, it will be basically transferred to this specific service right here, and that will be leading to right here the API service. So here the we will be basically posting the object to this um, this localhost URL right here, and sending the object to them. And then we'll be moving on to the Java code, the backend code right here. So after such, we'll be basically the object will be transferred to here, and the object will be basically set under data manager, and then data manager will basically take this information and send it to the sorting data class. So now we'll be moving on to the sorting data class. uh, yes, a small mistake there. We'll be sending to the data manager. Under the data manager class, we'll have a data sort method, and we'll be sending the data there. And we can now move on to data manager. So here, how the process is, the entirety of the detection process commences from here onwards. So first off, we'll be generating we'll be generating basically a user a special user folder for this particular interaction, and we'll be basically giving them a specific ID and creating a folder for them. And then off, we'll be creating a text document of all the information that we have gathered, basically the information that we gotten from the object, and like name, age, gender, and whatnot. And then we'll be basically calling the model for the first time. So here basically we'll be like using the buffer for opening the basically opening command the control panel from this location mentioned right here. And we'll be basically inputting the command to run the YOLO model right here as such with the image right here. uh, and after we can move on to the other functions. And after that, after the the detection is completed, we'll be basically getting this prompt here. And then moving on to moving directory. Basically what we'll be doing here is so after the detection is commenced, there will be a text document that will be generated from within the YOLO detection code, the detection code, and the image as well. So the image as well right here. So we'll be basically transferring these two documents back to the generated file for the user. And after that has been commenced, we'll basically be deleting the generated file in the we'll be deleting the generated file in the YOLO model. And then we will be moving on to reading the information within the text file that has been generated within the YOLO code. So here basically what we'll be looking for is we're trying to find out what kind of result that we have actually gotten from the text detection. So we will be checking if they have gotten class 1 of anterior crowding, or if it's anterior spacing, or of occlusion. So after that, these are basically keywords that have been defined from the YOLO model with the creation of the YOLO models themselves. And then we will be basically stating we'll be yeah. So here we'll be reading the document right over here, and then we'll be basically defining the keywords that we'll be looking for from those from that string file, and then basically creating boolean values of if the if the keyword is actually consisting within that line of string. And if let's say we have gotten anterior crowding, then that will make the found one value true, and then the next steps of detection will commence. Basically then we'll be moving on to things like severity checking severity here. So this will be the severity checking model over here. That will be commencing, and after that has been concluded, the files will be moved back to the user file, and then we'll be basically starting basically we'll be starting on location detection, and then after that location detection will be commencing here, and then we'll be concluding after deleting the files that will be generated by the YOLO model. So after that, three detections have been completed of malocclusion type, then malocclusion severity. The severity has been commenced under crowding, and under crowding the location detection has also been done, and then we'll move on to the other steps. So the if we have gotten positive for any other results such as spacing, the same kind of process sort of occurs as to getting detection from the doing detection for the location and the severity here, and the differentiation is on only the if the status we get is occlusal status. So if we get occlusal status, we'll basically running the second malocclusive model. So we'll be basically using the same image on on our second malocclusive model, and here after we will run this information, we will transfer the file back to the user file here, and then we'll basically read the file information, and then we will see if we can find any of these keywords here. So either upper proclination, lower proclination, or occlusal status. So if after we check that, so under these categories we'll be basically if if we get let's say if we get proclination, we'll be running this function. If we get upper proclination, we'll be running under this if condition. If we get lower, we are running under this condition, and if we found occlusion, we'll be running under this condition. So the same process of we can take a look at like same process of having severity checked will be happening here as well. Same process as mentioned before. If we can just like see, like if it's occlusal, we'll be basically saying that we have gotten occlusal status here, and after that we'll be returning the file to the analysis method in the data analysis class here. So we can move on to here now. So this is the data analysis class. So basically what this class is doing is basically structuring the information, and basically constructing an object with the detected data basically. So here basically what we'll be doing is under what kind of detection result we have gotten, we'll basically be be adding all this new information to this created array list right here. So under that we'll be under the conditions of if certain keywords are mentioned under certain results, we'll be basically adding them right here. So under that we'll be basically converting the detected image into bytes, and into byte format, and creating a string with it, and then basically adding that to inside the list as well as mentioned here. And here we'll be basically doing some error management as well. If any error has been occurred, we'll be sending an error message through this object as well. As such, we'll be basically under what kind of results we have gotten, we'll be basically putting information inside these objects here. So the only difference between some of these, if we can go up here, we can see some different if conditions right here. So what the difference between them is, since the sum of the detections will be limited to only uh, only severity and not location, and some will be only something like occlusion will be only limited to only the detection of the classification only. So therefore the depending on what kind of result we get, the object size would be different, going from 6 to 4 to 2 basically. And then we after all of this has been commenced, we have basically returned this value of result list here back to the original API call here. So basically with this API can be used for posting and getting as well. So we'll be basically returning this array this array list back to the front end using the using Spring. So after that, the method will be basically uh, from here we'll be basically getting this getting this object back here. We'll be naming some of the results that we have gotten right here, and basically from the results we have gotten, we will be from the length we will be deciding what kind of result we have been we've gotten. So if we get the length of 6, will be that will basically mean that we have either gotten anterior crowding or anterior spacing. So we'll be basically moving on to that. So moving on to that. So here we'll be basically converting the images to the three images we have gotten under the three detections to back into a PNG again from byte. Then we'll be basically getting all the value, setting all the values that we got here as well. Then here we'll be basically see the keywords that we have gotten, and compare them with the results. Compare them with the results that we have gotten from the object. So this code is basically primarily formed to depending on what type of information that we have uncovered from the detection. Under those conditions, what kind of information that we have to provide for the user. There has been error handling as well, error handling done here as well. If if a certain error has caused error has been caused, we will basically redirect the user to the informations page where they can basically learn how to take the image. So after all of these functions, all of these conditions, like leading to uh, the providing information for the user. uh, so we'll be basically the other we'll basically be displaying all these functions to the user, and these all are basically normal logic for the scripts, and what to display and whatnot. And here are the some of the other functions that are available, which will be used to navigate to the different applications, different processes that the system provides. And this will conclude the explanation of the code base of the SimpliSAE application. So in this segment, we'll be basically going over the evaluations that were received for the SimpliSAE solution. So we have gotten evaluations from two domain experts, two senior dental surgeons, and two technical experts. If we were to move on, we have as you can see here, we have received some positive feedback the from the domain experts, as to say, like they consider this approach to be a modern approach to this kind of industry. It's very useful, very user friendly for them, and they feel like this application would encourage users from basically seeking medical attention as well. And their overall feedback for the whether overall feedback for that as well. And then we have a prototype, a group study that was conducted under the features of the prototype. So here we have a basic overall feedback from the group testing that we have done. So here we have seen like some positive feedback and some future some feedback for the future development as well here. So usability feedback here as well. And for technical feedback, as you can see here, we have some meetings with technical specialists and technical specialists regarding the application, and we have received a lot of good feedback and positive feedback. Unfortunately, at the time of recording, we have only received only one response from one of the technical uh, experts from as for a review. We will be expecting the other response shortly after a few days. So for future enhancements, we actually have a couple of statements that we would like to add. First off is the combining of the two uh, malocclusive detection models. This is a condition that we had to proceed with due to the lack of power and lack of some of the hardware facilities that we have had during the creation of this during development of the system. Therefore, if we had the correct systems, we will be able to uh, basically combine these two models together, and then this will actually give a lot more faster result as well, and would give better accuracy according to the findings we got from the testing segments. So, and then the other improvements that we can actually add is including more variations of malocclusion classes. So this will basically give a overall like broaden the amount of types of malocclusions that we'll be able to get, and give a better analysis for uh, the user rather than a bit more generalized one. And then we can we have other another one with a medium priority, with basically to generate an image that basically has the after to generate an image that gives the after treatment uh, effect of a image, so the user can basically compare the difference between the after image and the image of their occlusal status right now, in order to give a clear description, clear comparison between the two, to encourage them for going seeking medical attention for this kind of issue.